Assalamualaikum and good day everyone. Today for the subject IHS246 we will be presenting on airborne chemicals in industry with a specific focus on toluene as our chosen chemical. Before we start with the presentation, let's get to know our group members. Airborne chemicals in industry aren't just chemicals in air. They are a major route of exposure and a core concern in industrial hygiene. Airborne chemicals are hazardous substances that are released into the thin air in the workplace where they can be inhaled by workers. In simpler terms, they are chemicals that become part of the air, such as gas, vapor, dust, fume, or mist.
There are several types of airborne chemicals commonly found in an industrial workplace. First, dust. Dust consists of solid particles produced from mechanical processes such as cutting, grinding, or crushing. For example, wood dust in carpentry work. Next, respirable dust. Respirable dust refers to very fine particles that can penetrate deep into the lungs. For example, silica dust in construction work. Third, fume. Fumes are fine solid particles formed when metals are heated and then condensed in the air. For example, welding fumes. Fourth, fibers. Fibers are long, thin particles that can be inhaled into the lungs. For example, asbestos used in insulation materials. Then we have mist. Mist consists of tiny liquid droplets suspended in the air. For example, spray painting in the manufacturing. Next is gas. Gases are substances that exist in gaseous form at room temperature. For example, carbon monoxide from engine exhaust. Finally, vapors. Vapors are formed when liquids evaporate into the air. For example, solvents such as toluene.
Toluene is a commonly used industrial solvent. While it is widely used in many industries, it also poses a significant health safety risk if not properly managed. Toluene is a clear, colorless liquid with an aromatic sweet smell. It is classified as a volatile organic compound, also known as VOC, which means it easily evaporates into the thin air. Toluene is commonly found in products such as paint, thinners, and adhesive, and also coating. It is also used in industry like printing, rubber manufacturing, and is even a component of gasoline. Now, I will explain the health effect of toluene exposure, which can be divided into two categories, which are acute and chronic effect. For acute effect, short-term exposure can cause headache, dizziness, fatigue, confusion, and irritation to the eyes, nose, and throat. In high concentration, it may lead to unconsciousness. For chronic effect, long-term exposure can damage the nervous system, causing memory loss and poor coordination. It may also affect the liver and kidney and pose reproductive risk. Overall, toluene can have serious health impact, especially with prolonged or high exposure.
For monitoring methods is used by NIOSH 1501. So first, we perform a pre-calibration to ensure the sampling pump is working correctly. The flow rate must be accurate because it determines how much air is collected. Next is preparations, where we connect the charcoal tube and place it in the worker's breathing zones. This is ensures where measures what the workers actually inhales. During the sampling, the pump pulls air through the tube and toluene vapor is trapped in the uh, charcoal. This can be done for a short period for over the entire work shift. After sampling, we perform post calibration to check if the pump flow rate has changed. If there is a big difference, the sample may not be valid. Finally, the sample is sealed and sent to the lab for gas chromatography analysis, which is determine the concentration of tolerance. Next, we go to the sampling trains. The sampling train is used to collect airborne toluenes directly from the workers' breathing zones. The pumps is calibrated to maintain a consistent flow rate, which is important for accurate measurements. The tubing must be airtight to prevent a leak that could affect results. The charcoal tube is the key component. It contains two sections: a front section from that collect most of the toluenes and the backup sections. If toluenes reach the backup section, it means the front section is overloaded. This collect breakthrough. This setup ensures the sample collected is reliable and represents actual exposure.
Next, we are moving to the calibration tree. Before and after sampling, calibration is conducted to ensure the sampling pump operate at the correct airflow rate for accurate chemical exposure monitoring. There are a few calibration train components, which is primary flow calibrator, sampling pump, tubing, and also charcoal tube. Okay, so we are moving to the primary flow calibrator. So, what is primary flow calibrator used for? First is to measure the exact airflow rate passing through the system. Second is to detect flow inconsistency before and after the sampling. Third, to ensure the compliance with standard monitoring method. Second is sampling pump. So, sampling pump is used to maintain constant airflow throughout the sampling period. Second is to simulate worker inhalation exposure and also enables collection of airborne contaminant over time. The third one is tubing. Tubing is used to connect the calibrator, pump, and charcoal tube into one system, maintain system stability during calibration and sampling, and also provide an airtight pathway for airflow. And the last one is charcoal tube. Charcoal tube is used to absorb airborne and organic vapor and chemical contaminant. It serves as the sampling media for vapor collection and also trap hazardous substance for laboratory analysis. Next, we are moving to the sampling procedure. At sampling procedure, we have four procedure that we have to follow, which is pre-sampling, sampling, post-sampling, and analysis. First, we are going to the pre-sampling calibration. First, we have to turn on the pump for 5 minutes, then complete the calibration form, break both ends of the charcoal tube, then connect to the calibration train, which is pump, is connected to the charcoal tube, also tubing and to the calibrator. Next is we have to check and adjust the flow rate to 0.2 liter per minute plus minus 5%, and also we have to repeat the calibration 3 times and calculate the average flow rate. Next is sampling. First, we have to complete the field data form. Second, attach the pump to the worker. Third, place the tube in the worker breathing zone for like 30 cm from the worker nose. Then the fourth is record the start time. Then conduct sampling for the required duration, record the stop time, and cap both ends of the tube and send to the laboratory. Next is post-sampling calibration. First, we have to repeat the calibration after the sampling, ensure the flow rate remains within plus minus 5%, and calculate the final average flow rate. Then we move to the last procedure, which is analysis. Samples are analyzed using gas chromatography (GC) to determine toluene concentration.
So next we move to the chemical exposure monitoring, which is we call CEM. CEM is a systematic process used to measure the amount of airborne chemical that workers are exposed to in the workplace. In this presentation, the chemical being monitored is toluene vapor. The purpose of CEM is to evaluate health risks and ensures that worker exposure remain within safe limit established by occupational safety standards. So, the first step in CEM is identifying the chemical hazard, which in this case is tolerance. After identifying the hazard, a suitable monitoring method is selected. For tolerance vapor, the NIOSH 1501 method is commonly used because it's reliable and specifically designed for organic vapors. Next, a sampling is carried out using a sampling train that includes a sampling pump, tubing, and a charcoal sorbent tubes. The collected samples are then sent to the laboratory for analysis using gas chromatography. After analysis, the results are compared with exposure limits such as the threshold limit value, also known as a TLV, and the permissible exposure limits or PLE. This limit help determine whether the exposure level is safe or hazardous. The chemical exposures monitoring is important because it helps protect workers' health, detect excessive exposure, and determine appropriate control measures such as improving ventilation system or personal protective equipment.
In conclusion, airborne chemicals can exist in different forms such as dust, fumes, fibers, mist, gas, and vapor. In this presentation, we focused on toluene, which is commonly used solvent that exists as vapors in industrial workplace. Proper monitoring using suitable methods, together with accurate calibration, is important to ensure reliable results and protect workers' health. Therefore, chemical exposure monitoring plays an important role in identifying hazard and maintaining a safe working environment. Thank you.